All right, Year 12, I'm going to do some of the questions from exercise 1208 that I think you'll need some help with. And the first one I'm going to do, I actually think I disagree with the answer in the back of the book and the work solutions. So let's have a look at it. It's question 7. A $2,000 loan is offered at 18% per annum with interest charged monthly over 3 years. If no repayment need be paid for the first 2 months, find the amount of each repayment. So this means the first 2 months I don't have to pay anything back. But I've looked at their work solutions because I was a bit worried about this. They say that no interest is being charged. I don't think that would be the case. So I'm going to do this as though interest would have been charged for those first 2 months. So after the first 2 months, so I'm just going to pick this up here and I'm going to use a different letter here. So I'm going to call this a principal. It's going to earn, and by the way, this is question 7. Get back here. 7. Get away, I don't want you. With the 18% per annum, which is going to equal, because it's per month, 18 divided by 12 divided by 100, which is going to be 0.015. I'll just show you that. 18 divided by 12 divided by 100. Righto. Now the time period, we're going to negate, so n is going to equal 3 times 12, but we're going to ignore the first 2 months, which is going to give us 34. But I reckon they will have charged you interest in those first 2 months. So the $2,000 that you're going to need to repay is going to be times 1.015 squared for the first 2 months. So 2,000 times 1.015 squared means that there's going to be $2,060.45. So I'm going to have $2,060.45. That's going to be what's in the how much you're going to owe at the end of the first month, when you make your first payment. So now I'm going to start. So this is why I reckon I'm going to be mine's going to be different from the back of the book or from the work solutions. So after the first payment, I'm going to have 2060.45 times 1.015 minus m. And after the second month, I'm going to have 2060.45 times 1.015 minus m times 1.015 minus m. Now, I'm going to have all the way to A34, which is going to be 2060.45 times 1.015. Oh, sorry, and that should have been squared up there. 15 to the 34 minus m outside of 1 plus 1.015 ... and it's going to be 1 less, 1.015 to 33. And what are these things in here? A equals 1, R equals 1.015, and N equals 34. So, what have I got? 0, because that's how much it's going to be worth at the end of that. It's 2060.45 times 1.015 to the 34 minus m times s to 34. I'll take all this over the other side. So I get m times s of 34, equals 2060.45 times 1.015 to the 34. So the repayments will be 2060.45 times 1.015 to the 34 over, and now I'm going to sub all these things in for S34. So 1, even though I know that one makes no difference, I'm going to put in so that if an examiner were watching this, they go, oh, this person knows what they're doing, 1.015 to the 34 minus 1 over 1.015 minus 1. And that is the most important bit. Please show it. So I've got 20, so that's my answer. So I'm going to go here, and that's my answer was 206.45 times 1.015 to the power of 34. Come down here. I'm not going to put the 1 in this time. 1.015 to the power, too many powers there, to the power of 34 minus 1. Didn't need those parentheses, but anyway, and 1.015 minus 1. Now, well, I've got exactly the same answer, which surprises me. That's 77.81, which is what they got. And maybe it's the $60 is inconsequential. So 77.8064. 8064 ... So $77.81. Because I've checked in their working, and they don't in theirs, that bit there is 2,000. And I think because the $60.45 is so inconsequential over 34 payments, it hasn't even registered. But anyway, I might check their working in a minute. Now, everything else is the same. So let's go. Part B. And this is the only difference. Come here. So that was A. And B was, and this is so easy, how much will be paid back altogether? And they're trying to get you to understand, well, how much you're paying. So you're paying back 34 of those monthly repayments. 34 times 77.81. I've still got that in my calculator, so I'm just going to go times 34. $2,645.42. $2,645.42. Now, if the next question would be, how much interest did you pay? And you paid $645.42 because you borrowed $2,000. And how much of that would be, well, you'd have to put that over the 2,000, times it by 100 and divide by 3 because it's over 3 years to get the flat rate of interest. All right, so that was question 7. I need to do question 8 because this is going to be a little bit harder. All right, so I'll clear some space here. And let's have a look at question 8. So Brianna thinks she can afford mortgage repayments of $800. So she's buying a house. Good on you, Brianna. Get ahead of the game. 8. and $800 a month, and she wants to do it over 25 years, normal life of or term of a loan, and we need to work out how much she can borrow. So we go after the first month, some amount, I'm going to call it P, times 11.5% per annum. 11.5% per annum. So this is going to be, and this is where you're going to have trouble. So the interest rate is 11.5% per annum, which is going to be a month, 11.5 divided by 12 divided by 100, which when you do on your calculator, 11.5 divided by 12 divided by 100 is a recurring decimal. So I'm going to leave it as that. So I'm going to write 11.5 divided by 12 divided by 100. And it's 1 plus. It's 1 plus that. Because it's 1 point whatever. Oh, minus, now we know that Brianna wants to pay $800 a month. A2 is going to be the principal times 1 plus 11.5 divided by 12 divided by 100 minus 800 times that all again, 1 plus 11.5 divided by 12 divided by 100 minus 800. This is going to go on for 25 years. So 25 times 12, 300. So eventually we're going to get down here to A of 300. And we're going to get this principal times 1 plus, and by the way, that's squared, 11.5 divided by 12 divided by 100 to the 300 minus 800 times 1 plus 11.5 divided by 12 divided by 100 to the 299 dot 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 dot, and they'll have an 800 at the back. Minus 800. I factorise out the 800, so I get this principal 1 plus 11.5 divided by 12 divided by 100 to the 300. Minus 800. Turn the series around, so I've got 1 at the front, 1 plus 11.5 divided by 12 divided by 100 plus dot 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 1 plus, look at that, 1 plus 11.5, so 1 plus 11.5 divided by 12 divided by 100 to the 299. Righto, I want my A. My A is 1. My R equals 1 plus 11.5 divided by 12 divided by 100. Now we could have used the rounded version of this, but over a long period of time, and N equals 300. There are going to be 300 of those. Now we know that there should be nothing left. So I'm going to take this over the other side. And remember, that's 800 times S of 300. So I'm going to get 800 times S of 300 equals P on 1 plus 11.5 divided by 12 divided by 100 to the 300. And that's times that, so I'm just going to divide by that. And now I'm going to write everything because this is a critical line. So I'm going to have 800 times, and then this is my series. This is my series here. So my A is 1, and even though it doesn't affect it, I'm going to put it in 1. And then I'm going to write this whole thing out. 1 plus 11.5 divided by 12 divided by 100 to the power of 300 minus 1. All over 1 plus 11.5 divided by 12 divided by 100 minus 1. That's my S of 300. And it's all over 1 plus 11.5 divided by 12 divided by 100 to the power of 300. And that will give me my principal. Now, if you try and type that into your calculator, it's too big. It's too big an algorithm. Your calculator won't deal with it. So what I'm going to do is I'm going to use the memory in my calculator. I'm going to go get that 1 plus 11.5 divided by 12 divided by 100 and make that my answer. So let's do that. 1 plus 11.5 divided by 12 divided by 100. And there's that number. And it's now in my answer. So now I'm going to type in the whole thing. So I've got 800 times parentheses. I've got another fraction here. I don't need the 1. I only put it in so that the examiner could see it. I know it makes no bearing on this. So I've got my answer, because that was that 1 plus 11.5 divided by 12 to the power of 300 minus 1. Come down to the bottom. I don't need parentheses. The vinculum groups the top from the bottom. And I get my answer. Whoops, too many answers there. Minus 1. I go to the end, put a parentheses. I come downstairs and I just go, my answer to the power of 300. And that's the correct answer, $78,703.83. So $78,703.83 is how much she can borrow, but they only want it to the nearest 100. So $78,700 is all she can afford to borrow. She won't be getting a very good house for that. She'll need to pay back more if she wants a more expensive house. Okay, that was question 8. Let's have a look at the other ones you have to do. So I'm just going to the website on my other computer. So 7 and 8, 11. 11, right, Amy borrowed money. How much did she borrow? Well, that's exactly the same as the one I've just done. All right. Although this time it's 7 years, 15%, it's $1,200 a month. So this person can pay back more, but it's only over 7 years, so won't be able to borrow that much. 13, Danny buys a home cinema system for $10,000. He pays $1,500 deposit and borrows the balance. So the amount he's going to pay back borrowing is $10,000 minus the $1,500. It's 18%, 4 years, and then you find out how much each monthly repayment is and how much did Danny pay altogether. Don't forget, Danny paid the $1,500 deposit as well as all the repayments. So it's going to be $1,500 plus 4 times 12 times whatever they're paying back. The last one I want to do is 15 and 16, but I'm not going to do 15 because that's the same. All right, 15's the same. But I do want to do 16 because it's showing you how you get that magic number in the table. So here we go, 16. I'll just get rid of this. Righto. So 16. Using the loan table on page 5, how much the monthly repayments of $1,000 over 10 years. So, okay, so 16A. 16A. So 10 years, 4.5% per annum, and it's $1,000. So I'm looking in the 10 years, $4,500. So I have to go back to 557. Okay, so here we go. So it was 10 years, 4.5%. And there it is. 10.36. So let's go back. So from the table, $10.36 a month for 10 years. All right, so 10 times 12 times 10.36, and that'll give you a number over 1,000. And I'll just check the solutions to make sure we're right. 14, 15, 16, 10.36, we're right. Now, show that this table, this value is correct. So we're going to do the same thing. So A1, $1,000 times, now 4.5%, so 4.5 divided by 12, 4.5 divided by 12 divided by 100. So 1.000375. So 1.000375. That's the interest rate minus M. Remember, M is what we're going to find. A2, 1,000 times 1.000375 squared minus M times 1.000375 minus M. Okay, we're going to do this for 10 years every month. So 10 times 12, we're going to A120. We're going to have 1,000, 1.000375 to the 120 minus M, 1.000375 to the 119 minus ... minus M. Righto. So A120 equals 1,000 times 1.000375 to the 120 minus M times S of 120. And what is 1? Now, if I rewrote this the other way, I get 1 plus 1.000375 plus ... I'm going to take the M out here, so I've got my minus M. all the way 1.0000375 to the 119. So my A equals 1, my R equals 1.0000375, and my N equals 120. Okay. Now, we know at the end of that time, the value of the loan will be 0. Excuse me. And we get 1,000, 1.0000375 to the 120 minus M times S of 120. I'm going to take that M and that 120 over and then divide by it. So in the end, I'm going to have M equals 1,000. 1.0000375 over 120, and I'm going to divide by S of 120. And this is a line that you must have. So my S of 120 will be, even though I don't need to worry about the 1, I'm going to put in 1.0000375 to the 120 minus 1 all over 1.0000375 to the 120. There's no to the 120 there, minus 1. And again, please remember, that is your most important line. That's showing everything. Now, if I just add 1 to that, that's now my answer. So I can do what I did the other time. So I go 1,000, I'm going to set it up, 1,000 times my answer to the power of 120 over another fraction here, my answer to the power of 120 minus 1, I don't need brackets because, and I get my answer minus 1. And I must have done something wrong because I'm getting 8.52. So I'm going to do it from scratch again. It is 4.5%, isn't it? 4.5. Let's just double check I've got that right. 4.5 divided by 12 divided by 100. Oh, it's only 1 0. Okay. So all the way through here, I have to take a 0 out. Now we're right, so and that's what I mean. And I wouldn't have realised that because it was, I would have because I'm doing a proof. So there's my answer. I must have divided by 1,000 the first time. Add 1 to that, and there's my new answer. So let's try this again. So 1,000 times my answer to the power of 120, down the bottom, new fraction, I don't need the 1, so I go my answer to the power of 120 minus 1 all over my answer minus 1. And there we go. Now, I would write all of that so that they know. So 10.36384, 10.36384, 088, which rounds to 10.36. And that is that magic number that they've created in the table. And they've done it by doing exactly that, because that table is For $1,000, it's in thousands of dollars, and it's in months and 4.5%. Now, they also asked in B, well, you don't have, that's it, that's all you have to do. Although they've gone, show this time, using the loan, find the amount of the monthly repayments. And then they've gone on to multiply by 12. Why have they done that? Show this value is correct. Show this value is correct. Why have they multiplied by 12? They must have decided they wanted a yearly amount. I don't understand why they've times by 12 in the work solutions, but we've shown that the answer is correct because we've achieved the same result, which is 10.36. All right.